Okay, time for a new trick. Okay, we've been looking at paths that are the solution sets to algebraic equation of the form y equals mx plus b. Yeah, and there's a better way because y equals mx plus b cannot have the infinite slope. M can't be infinity in there, so there's always one direction that you can't really follow. Uh, Now, you know what? I'm about to start a sentence without a word. I'm about to start it with with something that is shorthand for a word. This lim here. So I'm gonna put in a since. That'll make me feel like a better writer. Okay. Since this limit in the direction of the line. Okay, now I want to have a better way to describe a line than just the solution set to y equals mx plus b. Hey, wait a minute. We covered that in the last part of this course where we did three-dimensional geometry, right? Okay, so the line parameterized by, now the way that we did these parameterizations is we had a vector for direction that was like m, and then we had an initial point. And let's see, we want our initial point to be 1, 1. That way we know that our line here, parameterized this way, will pass through 1, 1, in particular when t is 0. And the direction we want to be arbitrary, so let's put in two arbitrary numbers, a and b. So a and b is the generalization of m to any direction. And this same treatment will work in 2, 3, 4, 5, 6, 7, or 89 dimensions. You would simply have 89 arbitrary numbers here for the various analogies of slope, if you will. And that would give us every possible direction. In fact, we're doing every direction multiple times. So, I mean, if this was uh, 1 over square root of 2, and this is 1 over square root of 2, that's a direction. And 2 over square root of 2, 2 over square root of 2 is has the same direction, but is a different vector. So, because we're not insisting on unit vectors right here, we're going over every direction multiple times. Okay, that was just for nerds. All right. This limit in the direction of that, now let's see, that is AT plus 1 and BT plus 1. Okay, so what is that limit in the direction of that line? It is the limit as t goes to 0. Yeah, because that will give us the point 1, 1 of the natural log of absolute value of, I don't know why we got an absolute value. I guess it's just as good as a parentheses. Let's see, instead of x, we should write at plus 1. And instead of y, we should write bt plus 1. And we have now reduced a limit in two variables to a limit in one variable by picking a arbitrary direction. And you know how to evaluate limits in one variable, just t. And we are meant to reduce to something that we know how to do from the past. So this is the natural log of 1 plus 0 plus 1 squared, that is 1. And 0 plus 1 squared, that also is 1. Yeah. 0 plus 1 squared, and 0 plus 1 squared. Okay, no, there's a natural log of 2. Okay. Now, we really did check every single direction, even straight up and down, right? So the straight up and down of direction would have 0 and 1, or 0 and 5. So that we would move only up and down, and our first component, our x value, would be forever stuck at 1 on that direction. We covered that this time, and we didn't in the past in my previous videos. Okay, now we found that this was independent of a and b, and I think that you can see pretty readily how a and b vanish typically. We can say this is independent of direction. The limit in two variables is natural log of 2.